Hey Sergio, so you asked for a little more information on this question. So it's asking for the degree and then I think it was what do they call it, the real roots. Sometimes it's solutions, zeros, x-intercepts, they're all the same thing. It's what would I plug in for these x's to make it come out to zero. So that's what they mean by the real roots. So this one factors, so I'll do that. So I can take out a GCF of x to the fifth, and that's going to leave x squared minus 36 equals 0. And then this is a difference of squares, so I can factor that further. X to the fifth, x plus 6, and x minus 6. So notice this was the degree of this, so the degree was 7, because that's the highest power. And it's still 7 down here. These are to the first, so I got 1, 2, 3, 4, 5 x's. And so I'm going to have as many zeros as I have as the degree of the polynomial. So x to the fifth equals 0, then, well, x would be 0, right? Because 0 to the fifth is 0. So this is multiplicity 5 because it's to the fifth power. So that 0 is counting as 5 of the zeros because it's what's called a repeated root because there's 5 x's. And then with each of these, x plus 6 equals 0, bring it over, that's going to make a negative 6. And then likewise, the negative one will make a positive 6. And those are both multiplicity 1. Multiplicity, there we go. And that's because these are to the first power. And so those are 5, 6, 7, that matches our degree. So those would be our zeros or our real roots and their multiplicities. And then just to compare that to something that would have something that wasn't real roots, let's say I had x to the fourth and then plus 4x squared equals 0. So this time I should get 4 zeros because my degree is 4. If I do the same factoring, x squared plus 4 equals 0. So this time I'm going to get x equals 0, and that would be multiplicity 2. Because of the squared, but this piece doesn't have real roots. It doesn't have any real zeros. So if I went to solve it, I can't factor because of the plus. I bring the 4 over, and then I can root both sides, and I can make sure I get the plus or minus. So what I get is x equals plus or minus negative 4, which is plus or minus 2i. So then I have solutions of 2i and negative 2i. And those are both multiplicity 1. So that's 1, 2, and then 3, 4 zeros here. So this is what it looks like when it has imaginary zeros or complex solutions. But the number of solutions is always going to match the degree of the polynomial. So hopefully somewhere in there I answered whatever it was that was kind of bothering you about that problem.